If I look at a machine and I look at its network configuration, look at the adapter details, and go to IPv4 or IPv6, as part of the properties, I can define static IP addresses, which includes its IP address, subnet mask, gateway, and also DNS information, or I can say obtain an IP address automatically. Typically for server operating systems in the data center, IP addresses are statically assigned. You want to make sure they always have the same IP address, as they may be offering services to other clients in the environment, and even with DNS time to live configurations, it can be problematic if servers change their IP address. But for your desktops, you really don't want to have to manually define the IP configuration for every single machine. So it's very typical to say obtain an IP address automatically. When that's configured, when the machine starts up and periodically afterwards, it actually tries to get an IP address over the network using a boot P request. And I have a network trace here. You can see here a client, which currently does not have an IP address, sends out a broadcast because its destination is all ones, 255, 255, 255, 255, and this is a DHCP request, and its message type is discover. It's basically requesting an IP address. Now you can look at this packet in more detail, and you may actually see that it requests a certain IP address that maybe it's had in the past. So for example, I can see here, this machine previously had IP address 192.168.1.137, which was given by DHCP. So as part of its broadcast out to the network, it's saying, I need an IP address, and ideally this is the one I would like. I had this before. It then gets one or more offers from DHCP servers. So I can see that this was sent from one of my domain controllers, which are also my DHCP servers. And again, it's broadcasted out because there is no IP address yet for that machine, and it's replying, and it's an offer type. So this is saying, here's an offer of an IP address. And as part of that, I can see here's the IP address I'm actually offering you, and it's that one it requested. The client, which still doesn't have an IP address, now sends a request, and it's actually now of type request because it did a discovery. I need an IP address. It got an offer. And now it's actually sending out another broadcast to say, I'm requesting this particular IP address that I was offered. So now it's actually saying the requested IP address is this 137. And then that server says, yes, you can have the IP address. It's acknowledging that request. And that's really how DHCP works. It's an automatic configuration of the IP. I can actually go and look at my DHCP configuration. So I define a scope, which is a number of IP addresses, then I can offer out to my clients over the network. And I specify a lease duration. So the lease is saying this is how long you can keep that IP address for. And at 50% of that lease, so in this case 4 days, that machine will try and renew that IP address. So it's not going to run out with a few minutes left to spare. It's constantly going to try and renew that IP address. Now, what the right duration is depends on your environment. If these are standard desktops, then 8 days is a good number. If this is a wireless network where you have many clients coming in just for the day, you may want to set this lease to maybe a day. It's really up to you what makes the most sense for your environment. I give it a description. I can say how IP addresses should be registered in DNS. For example, I can ask that the DHCP server always perform the registration, even if it's not asked to, for example, for my legacy clients. I can configure what type of name protection is enabled on the scope, especially if it's a domain controller. I can integrate with network access protection and some other features that I'm going to talk about in more detail in future modules. I can then see the leases, the IP addresses I've actually given out in my environment. I can do particular reservations so that based on a machine's MAC address, it always gets given the same IP address. So this would be an option for servers. I could absolutely still configure my servers to use DHCP, but in DHCP, I would actually create reservations and say, well, maybe this is for one of my IIS servers. And I say, I always want this to get IP address 80, and here's its MAC address. So even though that server is calling out, asking for an IP, because there's a reservation linked to its MAC address, it would always get the same IP. So it's a nice way to still centrally control the IP configuration, but make sure servers always get the same IP address. I have options in terms of pointing to routers and DNS servers, domain names. There's lots of different options available. and you can actually go and select and scroll these down. So that's a high-level overview of Dynamic Host Configuration Protocol, and in the future modules we're going to dive into some of the more advanced concepts.